In this problem, we're given a circuit diagram here. It's pretty big, but it is not as bad as it looks. We need to use the mesh current method to find the current through the 196 volt source. So we're basically going to be finding the current that flows through this voltage right here, and it's represented as this current right here. Well, the mesh current method will kind of look something like this. We're going to have a current and it's going to flow through all of these individual parts. We have part 1, part 2, and then a third part up here. So we know that current's going to flow through all of these the same direction as well. So I'm going to start the current from the bottom left hand corner. It's going to go up to this side, down here, and then back here. And it's going to go this direction. It's going to do the same thing on our other side up here, because the current is flowing through here, and then across here, and then it's the same thing up here. So we're going to have our current looking like this. I'm just drawing rough sketches, but our current flow will be in here. So that is the directions of our currents. We know that we have an I1 now, we have an I2 and I3. We just made these current flows. It doesn't matter what direction it goes. I could have drawn the current to go this way instead, but then everything that we're going to be doing is just backwards. However, we'll still get the same answer, so it really doesn't matter. The key is consistency. So once you start a direction, you have to stay with that direction. So looking at our voltages, I'm going to draw their direction. It goes into the positive, out of the negative. So I'm going to do that for all of these. Now we can start with the mesh current method. I'm going to look at our I1 first. So for our I1, we know we can add all the resistors up because they are in series. We have a 10 ohm resistor, 5 ohm resistor, and 30 ohm resistor. This is going to give us a 45 ohms of resistance, and this is for I1. Now this 10 ohm resistor shares space with our I3 current. We have to subtract this I3 current because they're going in opposite directions. We should note that our I1 is going this way, and our I3 is going this way. Again, since they're going in opposite directions, we need to subtract it. So we're going to have a minus 10 ohms, and this is for our I3. We're also going to have to do the same thing for our 5 ohm resistor, because our current is going this way, and our I2 is going this way, which is in opposite directions. So we're going to have a minus, and then our 5 ohm resistor being multiplied by our I2. And this is not it. We're almost done, but we have this 40 volts right here. We also have this 90 volts right here. This 40 volts is going in the same way as our current, and so is this 90 volts. So we can just add them together. That's going to give us 130 volts. We'll just do a plus 130 right here, and this is in volts, set equal to 0. Now if I move the 130 over to the right side and then divide everything by ohms, we're going to get this. So this is the first equation for our mesh current method. Now we're going to look at the second equation, which is our I2. So I'm going to keep these in order. We're going to look at the I1 part first, because this 5 ohm resistor we know shares I1 and I2. So since it's going in opposite directions, we are going to have a negative 5 ohms times our I1. Now we're going to look at our I2. We know that this is going in our same direction, so we'll have our 5 ohm resistor plus our 4 ohm resistor plus our 2 ohm resistor. So this is going to give us 11 ohms of resistance times I2. Now we're going to look at our voltages. The 196 voltage is going in the same way, so we'll have a plus 196 volts. Our 90 volts is going in the opposite direction. Remember, our current is going up like this, and our volts going down like this. So we're going to have a minus 90 volts. This is all set equal to 0 also, and we got to still remember about this 4 ohm resistor. It's being shared with our I3, which is going in the opposite direction. So we're going to also have a minus 4 ohm times our I3. I'm going to combine these two because they're constants and then divide everything by ohms. And that's going to give us this formula right here. Now we're going to solve for our I3. So for our I3, we can look at the I1 part, this 10 ohm resistor. We know is in opposite direction, so we're going to have a minus 10 ohms times I1. We'll look at the 4 ohm resistor because it's being shared with I2. So we'll have a minus 4 ohms times I2. And then we can have a plus with all of our resistors added together in series, 20, 30, and 4. which is 34. So we're going to have 34 ohms of resistance for our I3, all set equal to 0. So we have all of our three formulas now, and I'm just going to plug it into a matrix calculator. For this, I'm going to be using Symbolab's matrix calculator. I have our first row right here, the second row right here, and the third row right here. And then we have X, Y, and Z, with our I1 being X, our I2 being Y, and our I3 being Z. These are just representative, they're not really changing anything. So when we run this, we're going to get that our X is -5, Z is -3, and Y is -13. We know that our X is a I1, so we're going to say that I1 is equal to -5. We know that our Y is equal to I2, so we're going to say I2 is equal to -13. And we know that our I3 is equal to Z, so this is going to be -3. So looking back here, we're going to look at the current flowing through our I196 volts. It's flowing like this. It's flowing with our current that we drew here. So we know it's in the same direction, so whatever sign we're going to get out of it is the sign we're leaving it. We don't need to put a negative in front of it because it's in the same direction. Now we're going to focus on our I2. This part is important because we're looking at just this part of our circuit diagram when we do the mesh current method. So looking at all of this, all of our resistors are in series. So that means all of the current flowing through this is going to be the same. And we know that our I2, we just found our I2 to be -13. -13 is flowing through this voltage. So that means our answer has to be -13, and this is in amps. So this is our answer and how to do this problem. If you want more problems like this, there will be a playlist linked below with all of the problems for Introduction to Circuit Analysis, as well as the notes I used to write this, study for this class, and help on the exam.